This air review is brought to you by Verizon. When the Navy and the Marine Corps look to securely and effectively modernize their voice communications, Verizon's suite of services, solutions, and contract vehicles are there to help meet mission needs.
Hi, I'm Jordan McDonald, and I'm at National Harbor for the 2024 Sea Air Space Conference. Today, I'm joined by Dr. Glen Henshaw, Senior Scientist for Robotics and Autonomous Systems at the Naval Research Laboratory. Thank you for joining us, Dr. Henshaw.
Nice to be here.
We've seen a lot of talk about AI in the past year, bringing it to all different facets of the military. I wanted to ask, how can the Navy leverage AI technology for its own use in its mission?
That's a really, really big question because AI encompasses a huge variety of techniques and systems. Some of them can be what you might call bolt-on, which is we can take an existing system and we can sort of AI-ify it to a certain extent. For instance, at NRL, one of the things we do is build spacecraft, and many of those spacecraft are gathering intelligence. Currently, a lot of that intelligence is generated by human beings, and that takes time and it takes bodies. And one of the things that you could imagine doing is building better systems that can automate the process of looking at imagery and understanding what's in it, and then categorizing it into things that the military is interested in and things that we really don't care about. Other things are going to require a much bigger rethink in how we go about our mission. So one of the ideas that's been discussed is that with autonomous aerial vehicles, you don't necessarily need an aircraft carrier in order to host the power of a carrier air wing. You can now have smaller autonomous systems that can be flown off of smaller vessels. And if every naval vessel becomes an aircraft carrier, that's a really big difference in how doctrinally how the Navy fights and how it procures systems, right? So there's a wide range of changes that I think we're going to see, and I've stopped predicting the future because AI has changed so much so quickly. Just over the last year, we've seen groundbreaking research products come out of OpenAI and Google and other Silicon Valley organizations that it's really hard to tell where we're going to be a year from now.
And thinking about, the amount of change and products and services and things that AI is being applied to, how do you maintain the desire to find some innovation there, but also keep data secure?
Yeah, so data security is a really big issue for the military, as you know. The thing about AI is that it's only as good as the data that you have, right? And in fact, there are known ways that you can spoof machine learning systems. If you have the ability to inject falsified data into them, you can actually attack them and cause them to hallucinate. One of the advantages that the U.S. has right now on the battlefield is data superiority, right? We have systems that can collect far higher quality data than anybody else. And maintaining that data is going to be maybe the single most important thing that we do, right? Leveraging data superiority into AI superiority, there should be a direct pipeline there. Now, one of the challenges is we've got to make sure that data stays secure, but the other challenge is if you're training an AI system, it really wants to have as much data as possible, and for some systems, as much different kinds of data as possible. And currently, the way that we keep our data secure is that we keep it in different silos, and a lot of it's classified, and you have to be vetted to be in that silo, and you really can't take data from one silo and mix it with data from another silo, right? That violates sort of the tenets of security protocol. But when we're training a large-scale AI system, you really do want to take all that data and mix it together into a form that the AI can learn on all of it. I don't know how to solve that problem right now, right? That's going to require the DoD to really think hard about how our existing system works and how we can change it in order to make it AI amenable. And that's way above my pay scale. Sorry.
I do want to ask about a problem that you are solving. You work with robots, as you mentioned, at the NRL. Could you sort of explain to me how AI is functioning in that development and how you're using AI to create better robots for the Navy?
Sure. So there's a kind of machine learning called reinforcement learning, and I could geek out about it, but that's not what we're doing here. So at a very high level, it's the kind of machine learning that you would use to control a robot to perform a task. So if you want robots to do your dishes, you're going to be using reinforcement learning. And the way that we train reinforcement learning is in simulation. If we're training robots to do the dishes, then we'll write a simulation of your kitchen with dirty dishes in it and a robot, and then we'll let the robot, through trial and error, figure out how to not drop plates on the floor and break them, and then we'll figure out how, we'll let the robot figure out on its own how to pick up a scrub brush and how to, wash the dirt off the dishes, and the only feedback we're giving it is whether it was successful or not at the end. It takes a lot of computing power to run that many high-quality simulations. You're typically talking about hundreds of thousands to millions of individual attempts at cleaning the dishes. Now, you and I know if you're getting your kid to do the dishes and it takes him or her 1 million trials, that's suboptimal, right? But that's the way that the robots work. They want to take on the order of millions of trials. As a consequence, running that many simulations historically has taken us months. So in order to train a robot to wash your dishes in your kitchen, you're talking about months of computing time, and that's really expensive. But in the last 2 years or so, that's really changed. NVIDIA in particular released some new software that lets us run somewhere between 1,000 and 10,000 more simulations at a time than we could before. And as a consequence, what used to take us months now takes us maybe an hour. So we're now at the point where I can train a robot to do a complex manipulation task literally over lunch, right? And that opens the door to the kinds of things that you can fine-tune a robot to do affordably. So 10 years from now, that hour might be down to 30 seconds. And you can imagine a sailor or a Marine that has a particular task they need to solve. There's a bomb that needs to be defused. There's a door that needs to be opened. There's a car that needs to be inspected. You can image that car with cameras, build a model, insert it in the sim, and train the robot to do that particular task that fast. And that will be a real game changer in terms of what we can think about robots doing.
Yeah, and thinking about what robots are doing, last year when you joined us, you mentioned the robot manipulation problem, the idea that it's hard to train a robot to do human tasks like RAS things. Can I ask how that's been going and how you're learning and how to tackle that issue?
Yep. So we are trying to apply these new software tools and figure out ways to build simulations of particular environments very quickly. And that's actually largely not a machine learning problem, it's more an interface problem. What tools do I need to give a user so that the user can very quickly model a scene and specify what they want the robot to do, and then we can have the robot run all the simulations it needs to figure out how to do that job. Unfortunately, we need funding, as is going to be a surprise to no academic anywhere, right? So if you've got a check for $100,000, I'll take that check. We're somewhere down that path, and we are looking for immediate wins that we can demonstrate to the Navy to make them interested enough to start to invest more money in that research portfolio.
Absolutely. Well, definitely keeping an eye out on that, and we'll love to hear about any new developments that come about. Dr. Henshaw, thank you for joining us today.
Nice talking to you.